All right, potential and kinetic energy. We have two samples of potential and kinetic energy. The first one is Mr. Scott and his wife right here. We're on our wedding, and afterwards we decided to go for a boat ride. We could be showing potential energy as we are resting on top of the tube. When it started moving, though, that was kinetic energy. And then when we were thrown from the tube, as we're being right here, about ready to be thrown into the water, we're showing kinetic energy as we're moving. Over here we have a roller coaster. And with this roller coaster, when the roller coaster is at the very top, there's a moment where it's showing potential energy, in that it has the potential to start coming down the slope. When it starts coming down the slope, it's demonstrating kinetic energy, which is the energy of motion, or potential energy. It has the potential of motion, but it's stationary. So here we have the potential motion, and then when it starts coming down, you have kinetic energy. Or as it loops around this way, it's coming down, you have the kinetic energy. On the other hand, when it's at its top crest up here, you have potential energy, and that it has the potential to move forward. So all energy is divided into potential energy and kinetic energy. As far as potential energy is concerned, you have gravitational potential energy. You have elastic potential energy, for instance, that would be like a rubber band. And then you have chemical potential energy. So what is potential energy? Energy that is stored and waiting to be used later is potential energy. And what is gravitational potential energy? It's potential energy due to objects of position, or objects in position. In other words, the gravity of the Earth is pulling on this weight. It has potential energy. If this string is cut, that energy comes down as a kinetic energy, but while it's waiting up here, it's potential energy. Here is an obvious example of potential energy. This poor little whatever that is about to get crushed when this comes down. That has the potential to create an extreme amount of energy. Don't look down, Rover. Good boy. Now, elastic potential energy is energy due to compression or expansion of an elastic object, which is basically a rubber band type of thing, or something that goes out and comes back like a rubber band. A basketball is going up and down due to the reflex of the ball once it hits the ground. This is an elastic object, and it has a potential energy. Chemical potential energy is energy stored within the chemical bonds of an object. Batteries are an obvious one. The chemical reaction that takes place within the battery can cause energy, and we can see that in a flashlight. Kinetic energy is easy. It's energy of an object due to its motion. Up here, we have the potential energy. It's not moving, but as soon as this string is cut, that energy is released, its potential is released, it drops down. As it's dropping down, it's creating, or as it's moving down, it's creating kinetic energy. Here you're seeing the roller coaster. As it's moving, you've got that kinetic energy taking place. Notice this graph, when it was at the crest, it had the least amount of kinetic energy, but it had the most potential energy right here. Watch the chart, watch the graph. Potential energy comes up at this point. Same as right here, potential energy is going to come up. When it's moving, the faster it moves, the greater kinetic energy and the less potential energy. Again, as you've got potential energy, when the skier is on the hill, there's a gravitational force working for or working with him, pulling him down, creating potential energy, as you see over here. So as that potential energy is realized as he's coming down, and he reaches here now, that potential energy, well, it's just not there any longer. It's been turned into a kinetic energy, or the energy of motion.